Hey, welcome back to school. Happy New Year. Hope you have a great year to come. 2021, gonna be the best year ever, right? We'll see. All right, so I'm gonna go over 2-4 again with you real quick. Little review here, and then you guys are gonna do some more practice from 2-4. I saw some X's from some of you guys, so you want to make sure to figure out which ones you're missing. If you're really confident on these ones, feel free to watch the video fast to get a quick summary. So anyhow, this lesson's on complex numbers, which are real numbers combined with the imaginary numbers. So they look like a plus bi or a minus bi. So some things to remember. What is an imaginary number? An imaginary number, mathematically, we define as the square root of -1. Okay? No number times itself could give you -1, so we use I to stand for that number. Now, if this is true, and we square I, we get the equation I squared equals -1. Okay, so you want to use this fact and pretty much this fact throughout the lesson. Okay, so you got to keep those two things in mind. And on some problems, you need to use the complex conjugate to get rid of imaginary numbers if they're on the bottom of a fraction. All right, and so if you have a imaginary number in the bottom of a fraction, you need to multiply the top and bottom by the complex conjugate, which is the same real part, but the opposite of the imaginary part. Okay, so if it was this, then you make it a plus, and if it was plus, you make it a minus. All right, so here are a couple problems that people missed. This one here, you basically have to remember that there's a minus sign here, so you're not foiling on this one. You are subtracting, okay? Even if it didn't have subtract there, you need to subtract. So you have to distribute that minus sign in, okay? And so that's going to change the sign on 6 to be -6, and the sign on -6i to be +6i. All right? And when you're combining two imaginary numbers, you just combine the real parts. So 4 minus 6 is -2, and then combine the imaginary parts. 3i plus 6i is 9i. So that's basically it for that one. Okay, so the next one here, you're multiplying two complex numbers, and when you do that, you're going to be doing good old FOIL. Okay, multiply the first terms, the outer terms, the inner, and the last. Okay, so the first terms, you're going to do 6 times 6, that's 36. The outer two, you got 6 times 2i, so that's 12i. The inner two terms, you got -2i times 6, so that's -12i. Okay, so outside and inside are actually opposites, so that will cancel nicely. And you have -2i plus 2i, so that's -4i squared. Okay, so these middle two terms cancel. Now, you might think, what can I do with the I squared? Well, remember this little fact here? Cha-ching! I squared is equal to -1. So since I squared is equal to -1, what we could do is rewrite this I squared as a -1. And so you have -4 times -1. And you have two negatives, which just make that into a plus. So you have 36 plus 4, and that becomes 40. All right? All right, now we're on to some tougher ones where you have to rewrite this imaginary number in standard form. And when they say standard form, it means like a plus bi or a minus bi. All right, in order to do that, you have to get rid of the I in the bottom. And like I said before, you have to use the conjugate of the denominator. So what's the conjugate of this denominator? Remember, keep the real part, so 5. Let's change the sign on the imaginary part, plus I. Okay, so on the top, you have 5 plus I. All right, now there is a shortcut here when you multiply a complex number by its conjugate. Okay, when you multiply a complex number by its conjugate, the result is always a squared plus b squared. Okay, where a is the real part and b is the number in front of the imaginary part. So here the denominator is going to be a squared, which is 5 squared, plus, okay, now b is an understood 1 here, because of 1i, so it would be 1 squared. Okay, so that's the shortcut. So you want to make sure to use this. It'll save you time. You could FOIL the bottom, okay, and then you realize that's what you would have left, a squared plus b squared, because the outside and the inside cancel, and then you have that negative I squared, which becomes plus a number there, so plus b squared. All right, now on the top you have to distribute. So you would have 2 plus 5, which is 10, and 2 times I, which is 2I. Okay. Now 5 squared is 25, plus 1 squared is 1, so you have 26 on the bottom. So you have 10 plus 2I over 26. Now you have to reduce this, so split up the fractions. 10 over 26. Those are both even numbers, so that gives you a clue. You can reduce that. And here you have 2 over 26. Now, since you want to run it as a plus bi, you want to pull out the I, like in front there, in front of the fraction. 10 over 26 reduces to 5/13. And 2 over 26 is 1/13. Okay, so you have 1/13 times I. And there you go. That would be standard form. Okay? Next one, a little bit harder, but the same basic problem. You have to get rid of the imaginary number in the denominator. Okay? It just says perform the indicated operation. That's kind of deceptive. I don't know why they said that in the directions here. Okay, so what is the complex conjugate? Well, 3 plus I, it would be 3 minus I. Okay, so that's what you're multiplying the top and bottom by. Remember the shortcut I taught you just a while ago, or a few seconds ago, if you weren't paying attention before Christmas. It's a squared plus b squared for the bottom. Okay, so the bottom becomes a squared plus b squared. So that would be 3 squared plus b, again, is 1. So we have 1 squared. That's the denominator. Now the numerator, you have to FOIL, okay, because it's not a conjugate times its partner, okay? You have to FOIL the whole top here. So you're going to do first term is 3 times 3. Outer term is 3 times I, so that's negative 3I. Inner term is negative 2I times 3, so that's negative 6I. Last term is negative 2I times negative I, so that's plus, negative times a negative is a plus, positive. 2I, I times I is I squared. Okay, so that's what it would look like. So on the bottom you would have 3 squared plus 1 squared, so you'd have 10. On the top we can, let's fix up the top a little bit, so 9 will be the same. Combine these two terms. Negative 3i minus 6i is negative 9i. You add them because they're the same signs. 2i squared. Now remember what we said with I squared? That's the same thing as negative 1. So negative 1 times 2 is just minus 2. And then we have 9 minus 2 is 7. So we have 7 minus 9. Sorry, it doesn't look like a 9. 7 minus 9i all over 10. And if you want to write it in the right, nice, pretty standard form, it would be 7/10. And none of this reduces. Minus 9/10 I. Okay, so that's what your answer would look like in standard form. Nice and pretty there. Okay. All right, now we're on to solving some equations using the square root property. Now remember what the square root property simply states is if you have x squared equals some number b, you could solve this by square rooting both sides, but when you square root both sides, you have to do plus or minus the square root of b, okay? And so basically you want to get the x squared by itself first, and then you square root both sides when you're doing this, okay? So to get rid of the 147, we're just going to subtract it from both sides. So we have x squared equals negative 147. And then we're going to use the square root property where we square root both sides, okay? And then as soon as we do that, we should remember it is plus minus. So you're left with x equals plus minus. Okay, now very first thing you want to think about doing is there's a negative underneath the square root. So you take out the I for that negative underneath the square root. So you have plus or minus square root of 147, okay? Now, you might need to simplify this square root. So you have to think, okay, are there any perfect squares, number times itself, that's a perfect square, like 81, 9 times 9 is 81, that's a perfect square, that go into 147. Okay, so you need to know all your perfect squares. So we got 81, that doesn't go into 147, 64, and you want to kind of work your way backwards from about half of that number. Okay, so 64 doesn't work. 49, 49. Okay, so use your calculator. 147 divided by 49 is actually equal to 3. So that's the one that you want to split this into. So you split 147 up into 49 times square root of 3. Okay, so this becomes these two, and then you take the square root of 49, it becomes 7, and you keep the square root of 3, square root of 3. Okay, so here is your final result in simplified form. If you don't simplify it, they're not going to take the answer, so make sure you simplify it, and there you go. All right, one more here. Basically the same thing. You got to get the x squared by itself, so we're going to start by dividing it by 2. So we would have x squared equals negative 49. Okay. Then you're going to use the square root property again. Square root both sides. Okay, and as soon as you do this, you should technically write the plus minus in here. You could wait till the next step, but I'm trying to be technically correct here. So your answer then would be x equals plus or minus. Okay, so we would have a negative underneath the square root, so we pull that out as I. Now we do know the square root of 49, that's just 7. So your answer is plus or minus 7i. Okay, so that's a little sloppy there, but you get the point. It's plus or minus 7i. Okay, so those are all the ones that people had issues with. I hope that helped you guys. And try to do the new problems on Math Excel. And tomorrow we're going to have a little quiz on this. You might want to look back at the notes if you need more help, or the old videos. I'll post those. And I hope you guys have a great day. Bye-bye.